Okay, so today we're looking at question 1721, swapping nodes in a linked list. I don't know if it's swap or what. Yeah, but you're given, please excuse me if I pronounce it wrong. You're given the head of a linked list and an integer k. Return the head of the linked list after swapping the values of the kth node from the beginning and the kth node from the end. Note that the list is one indexed. So we're given like a few examples. We can see that in this case, k is 2, so we want to swap this node and the k from the end, so that's like node 4. So we return 1, 4, 3, 2, 5. And the second example, we have this pretty long-ish example. K is 5, so we go 1, 2, 3, 4, 5, and k 5 from the back, 1, 2, 3, 4, 5, that's 8. So we swap 7 and 8. And in an example where there is only one node in a linked list, we basically don't swap it. And if it just so happens that the kth node and the kth from the end node are the same node, don't swap it as well. So here are some constraints. Number of nodes is n and denoted by n, and k is less than n, and ranges from 1 to, both k and n ranges from 1 to 10 to the power of 5. So we won't have to deal with the situation where it's like an empty linked list. And the node values ranges from 0 to 100. Yep, I guess that's it for the problem description. So let's just see, start talking about how we can go about solving this. Let's shrink this a bit. So let's just use example 2 for illustration. So we have 7, 9. Oh, I need to draw a shorter arrow, right? Because we have quite a few nodes. 6, 6, 7, 8, 3, 0, 9, 5. And we have k as 5. So what we can do is basically, okay, so we now already know which node is the kth node, right? That's like pretty straightforward because we just go like starting from here, we just go like 1, 2, 3, 4, 5. I mean, sorry, it's one index, so this is 1, 2, 3, 4, 5. This is our what do you call it? The k node, k pointer, right? But the problem is that we don't know what's the k from the nth node, right? And it's like we don't know the length as well, so we have to figure out like a way to find out which is the kth node from the end. So the approach to solving this is actually making use of the fast slow pointer approach, but in this case it's a little bit different from our usual fast slow pointer where we increment fast pointers by 2 steps and slow pointer by 1 step, right? So what we can do is we assign another pointer, fast pointer, to this at this position, and then we okay, maybe let's try a different color. Okay, fast p to this, and we start a pointer slow p. Okay, so now at this position we basically traverse the fast p until like the last node, so until this position, and at that point in time slow p will end up in the position of the kth node from the end. So let's try and see if that works. So from this point to this point we go 1 2 3 4 5 steps, right? So slow p goes 1 2 3 4 5. Just nice, we see it like ending up in this position. And at this point in time, what we want to do is basically let's use red, maybe green, okay, green sign. Swap these two values, and we can return our list. Yep, so this will work for other examples as well. So let's just try on example 1, case 1, case 2. So we have k pointer pointing to this. Let's draw this a bit further away. So we have k pointer to this, and fast pointer when it reaches this position, right? Slow p, okay, because fast pointer started off here, right? Slow p starts off here, and it's like right behind fast p, so slow p will end up here. Okay, so yep, we can then swap these two, and we're done. Okay, so now let us try implementing it. Yeah. So first off, initialize stuff, our pointers. So we have k pointer first. And we basically traverse, for range k, should it be k or okay, so in our example 2 we can see that we want k to go from this first node 1 2 3 4, so but k is 5, so we need to minus 1 to it. Okay, in this range, k pointer, we keep walking it down, and at this point we can point our fast pointer to it. So now we need to get our other pointer, the slow pointer, in place, right? So we'll do okay. Now that we have our fast pointers and slow pointers in the correct position, we can start walking the fast and slow pointers down to the last node, the fast pointer to the last node. So while fast pointer dot next, what we want to do is walk them down. Okay, now they're in their correct positions. We just have to swap the kth pointer with the slow pointer, their values, right? So and we return. Okay, let's try and see if this works. Okay. Okay, great. So that's it for today's video, and thank you for watching.